Hi, myself Sanjay Gaikwad. I am working as an assistant professor and head of the department, Mahatma Phule College, Panvel. Today, here we are discussing on the paper number 2, modern physics, and unit number 2. In that, the article name is fusion and fission. Okay, this is one of the mysterious concept in the nuclear reactions, chapter number 2. And in nature, generally, we observe the two types of reaction, that is the fusion reaction and fission reaction. Same in nuclear phenomena, there is a fusion and fission reactions takes place. So in the picture you can see that there are two types of nuclear reactions. One is nuclear fission and another is the nuclear fusion reaction. Name itself reflect that what is the fission. In fission reaction there is a breaking of the nucleus of heavy nucleus into two equal or nearly equal parent nuclei. Okay, when we are considering this in fission, when there is a neutron is bombarded on the uranium, here the uranium is a very heavy nucleus. When we are bombarding the projectile like neutron, then it split into the two parent nucleus like barium and krypton. And addition to that, the product particles are there, that is known as the neutrons. In the nuclear reactions, generally two parts are there. Like in chemical reactions, we can consider that the target nucleus, we are bombarding this by the projectile. Generally, projectiles are the light particles like alpha, beta, gamma, neutron, proton. Like this particle, we are bombarding on the target, which is already very heavy nucleus, and it split into two parts like product and product nucleus. Okay, this is already mentioned in this picture. You can see that is a nuclear fission and another is a nuclear fusion. In that, very light nucleus are come together like deuterium and tritium come together and form the new nucleus, that is the helium, and addition to that nuclear particle. Okay, means what? In the fission there is a splitting or you consider breaking of the heavy nucleus into two nearly equal parent nucleus, and addition to that nuclear particle. Why in the nuclear fusion reaction two light nuclear particles come together, fuse together and form the another nucleus like in the picture. Okay, so we will see some examples and details about that. First of all, that is a nuclear fission reaction. The nuclear fission reaction, firstly, when the uranium-235 is break down into two parts like barium and krypton, which is mentioned in the initial picture. With this reaction is mentioned by the French and Forsyth in 1939. This process is also, you can see that heavy nucleus split into nearly comparably same masses, and this process is called as the nuclear fission. Means breaking of the heavy nucleus into two nearly equal nuclei. This process is known as the nuclear fission, and in this process very large amount of energy is released. Very large amount of energy is released in this condition, and it is because mass of the parent nucleus is greater than the sum of the daughter elements produced after the nuclear fission, and this process is known as the nuclear fission reaction. And in this process the neutrons are emitted. Remember that this is one of the good website. You can video is there in YouTube. You can go through that one. You can get the idea about the nuclear fission. Another, this is the one of the reaction when neutron projectile is bombarded on the uranium-235. It is an unstable compound form, and this is breakdown, or you can see the fission fragments like barium and krypton, and addition to that, 3 neutrons are emitted. Addition to that, there is a very huge energy released in this reaction. Nearly, you can see that in the another example, when proton is bombarded on the upper nucleus, then there is a formed in sodium and krypton, sodium and potassium form with releasing of the one of the neutron. This reaction is invented by the Barger and Seaborg. Okay, see, another reaction is there. Some of the how much amount of energy is released in this reaction, we can get this with this information, and nearly 16 into 10 to 90 kilocalorie per kg energy emitted. See, another is the nuclear fusion reaction. In this, when deuterium is combined with the deuterium in the atmosphere of the sun, we observe that two deuterium and deuterium fuse together and form the helium, and this reaction takes place at the near the sun, and we can get the huge source of energy with the help of this Einstein's world famous equation E is equal to mc square. From this equation, we can see that the nuclear fusion is the process in which small nuclei are fused together to form the single heavy nucleus. The process in which small nuclei fuse together to form a single heavy nucleus. This process of nuclear reaction is called as the nuclear fusion, and one of the best example is this. Generally, what happens? We know very well about the conversion of mass into energy. Mass into energy. We know that, and mass converted to energy generally like when we are burning some mass, it can be converted to energy. When we are cracking the crackers, at that time we can get the sound energy like this one. Okay, this is one of the detail about the how energy is emitted from the fusion reaction. It is very small, like 24 million electron volt as compared to the earlier reaction. These are some references for the current lecture, that is the nuclear reaction, types of nuclear reaction. Thank you.